Recurrence relation. A rule that defines a term an as a function of previous term is called a recurrence relation. Okay, so if we can get an by some function of the previous term, तो हम इस तरह के relation को recurrence relation कहते हैं. Okay. So for example, the arithmetic sequence is a recurrence relation because I can get an from an minus 1, okay, by a rule. Similarly, geometric sequence P एक recurrence relation है because I can get an but by multiplying a constant to the previous term, okay. So sometimes we need to multiply previous values to obtain the multiple previous values to obtain the current term. Okay, so for example, here is a rule which says that f of k is equal to f of k minus 1 plus f of k minus 2. Okay, this is also a recurrence relation. Okay, recurrence relation says that to get f of k, I can apply a formula on the previous terms. Okay, previous जितनी भी terms हैं उसमें उसके ऊपर कोई formula apply करके I can get something for the current index, तो मैं उसको recurrence relation कहता हूँ. It does not say कि you have to get multiply something with the previous term or add something to the previous term. Yeah. So there's a pattern and sequence, and you can get the new value by applying some function on the previously known values. Okay. So here's, for example, Fibonacci sequence. It says that you can get f of k by adding the last two terms. Okay. Just to point this thing out, this sequence is neither arithmetic nor geometric. ये arithmetic भी नहीं है और ये geometric भी नहीं है. हाँ, but remember addition के लिए क्या आपके पास ये term थी, it must be a constant. इस केस में जो addition term है वो constant नहीं है, which means कि this is not an arithmetic relation. Okay, so f of k minus 2 की जगह यहाँ पे अगर कोई constant होता, so this must have been an arithmetic relation. But since it's not arithmetic. It's definitely not geometric. Okay, but it's still a recurrence relation because I can compute it by applying a function on previous terms. This thing has many application coding. You guys must have used recursion to, I don't know, implement stacks or queues or linked list or something. You might actually have computed Fibonacci or I don't know, factorials maybe. Okay, so that's there. Optimization, algorithm analysis में इसका बहुत ज़्यादा use है. Okay, so instead of analyzing the function जिसके अंदर recursion हो रही है, you analyze it in terms of recurrence formula उसका बना लेते हैं. और recurrence formula tells you how to compute the value of the function. Okay. You can convert miles to kilometers. You can apply, you find golden ratio. I'm not going into, you must look them up. Okay. All right. Applications में robot dynamics हैं, population growth है, जैसे आप लोग कह रहे थे अभी बैक्टीरिया की जो growth है, तो you can model it using recursion. Okay. It may not be geometric. कुछ species के case में it's geometric, कुछ cases में it's exponential, but it's always modeled using recurrences. Okay, recurrences आप use कर सकते हैं to model it. Economic models बनाने के लिए how economies grow. Here's an example. Salary of a guy in a year n is Sn. Okay, so for some year n, your salary is given by some formula Sfn. The guy gets $1,000 bonus at the end of the year. Okay. The salary of the subsequent year is 5% more than the income received by the employee in the previous year. Okay, so which includes the salary and the bonus. So you can actually compute the previous, the new salary using a recurrence relation. Okay, so you can tell me what's the salary in the first year, and I can tell you the salary in the 100th year if the guy lives up to, I don't know, 200 or something. I can actually find out the salary in the 100th year using just a recurrence relation without computing salary of every year. I can just apply some formula and compute it. So for example, the income in year n minus 1 is going to be S of n minus 1 plus 1,000. That's a bonus जिसको मिला था. 5% increase would be the 5% of this value. Okay, so the salary is going to be 1.05 times whatever this thing was, the previous salary thing, okay, which means that I can compute the salary using this formula, okay, and this is recurrence only because I have this thing in there, okay, ये जो मेरे पास previous year की term यहाँ पे मौजूद है ना, this makes this a recurrence formula. All right, summation of sequences. So you have this formula which says that you need to sum up I square, 1 square plus 2 square plus 3 square plus 4 square. You always use parentheses when you write these terms. So if you have I plus 1, so you can do this, okay? This is the famous Gauss story about computing sum of first 100 numbers. I'm sure you guys have heard it before. Have you guys? Yeah?
No,
You
sir.
haven't? All right, okay, you can waste 5 minutes of mine.
Oh, sir, ये पता है.
Okay. Okay. So कुछ लोग कह रहे हैं कि नहीं पता, तो let me. All right. So
हमें सरफराज में कोई
awesome. Okay, great.
program
Then you know it. I'm not gonna go in this. If you don't, तो just search Gauss story and how to sum first 100 numbers. Okay. All right. So sum of the first 100 numbers is 5050, and this is this number because it's n over 2 times n plus 1. Okay. Tips and tricks. So the first tip is that you can pull out a final term from the summation. So, for example, if you have to sum up numbers for so इसका मतलब तो मेरे ख्याल में आप सबको पता है. What does it mean? It means that it's the sum of am plus am plus 1 plus am plus 2 up till a n. Okay, so these are the sum of elements of the sequence starting from the mth element and ending at the nth element. Okay, जो भी आपका sequence था, let's say a0, a1, a2, so on. At some point you would have am, and at some other point you would have an, and then you would have an plus 1 and so on. Okay, तो ये जो बीच में सीक्वेंस के एलिमेंट्स हैं, इसका सम मैंने फाइंड आउट करना है, और इसको लिखने का तरीका ये है कि आई राइट दिस समेशन साइन ए के, और इसका जो इंडेक्स है आई रन इट फ्रॉम m to n. Okay, this is the starting index and this is the ending index. Okay, have you guys seen this sign before? You have? Yeah. Okay, awesome, great. So one of the tricks in finding this sum is that you somehow remove some of the terms. Okay, so यहाँ पे sequence में से मैंने last term remove कर दिया a of m. Okay, so the summation now runs from m to n minus 1. At times this helps you find the summation of the sequence. Okay, we'll see. So here's, for example, a thing. It's sum of 2j, where j goes from 0 to n. So if you want to remove the last term, you would get 2n out. 2n आपका बाहर निकल आएगा. Okay, and your sum would run from 0 to n minus 1. I'm not asking you to compute the sum. I'm just asking you how to remove the last term from the summation. Okay. Similarly, if your terms are 2 to the j minus 1, if you want to remove the last term, you would remove 2 to the j minus 1, where j is n plus 1, n plus 2. Okay, so you would get 2 to the j to the n plus 1, and the sum would now run from 0 to n plus 1. Okay, so I remove this is the last term, and then I have the remaining summation here. Okay, that's the way to remove the last term. Tip 2 is that you can change the variable of the summation. Okay, so and it helps at times. So for example, if you have an example which says that you need to sum k plus 2 cube, and k runs from 1 to n plus, it's just n, I think. K runs from 1 to n. So in this case, you can replace this index with, you want to replace it so that this thing becomes, यहाँ से +2 remove हो जाए. Okay, so so what would you do is you would replace k plus 2 with I. Okay, so if you replace k plus 2 with I, तो यहाँ पे I would get I cube. Okay, and what would 1 become यहाँ पे? So when k is equal to 1, I must be equal to what? देखो ये जो
3.
दोनों terms है ना, they depend on the value of the index. Okay, so the first term of the sequence was 1 plus 2 cube, right, which was 3 cube. Okay, so अब भी इस sequence की जो पहली term है, it must still be 3 cube. Okay, which means that you must start your index from 3 instead of 1. Okay, similarly the last term of the sequence was n plus
N plus 3.
n plus 2
2.
cube, right? And now the last term should also be this thing, which means that you need to replace I with this n with n plus 2. Okay, so if you replace this with n plus 2, you would get a summation of the form which goes from I is equal to 3 to n plus 2, and summation के अंदर आपके पास होगा I cube. Okay, these two summations are equal. ये वाला और ये वाला, ये दोनों एक दूसरे के equal. But now आपका जो फार्मूला है वो थोड़ा सा शायद सिंपल हो गया. You just need to compute summation of cube of an index. All right, so this is what we did. When analyzing the algorithm, we often run a cross-coding that involves some type of loop, and we need to count the number of times the loop is executed, right? We have seen this before. Sometimes things are easy to compute, like in here, I goes from 1 to n, and then sum is equal to sum plus I. But sometimes things are not so easy because the loop depends on the index of another loop. So for example, over here j runs from 1 to I. Okay, and I is not known. I is not a constant. I is a variable which lies in as a index of another loop. Okay, so इस केस में आपके पास जो फॉर्म आएगी वो डबल समेशन की होगी. So when it's not easy to count, we proceed by attempting to find a closed form to assist in counting operation. A closed form is an expression that can be computed by applying a fixed number of familiar operations. Okay, so for example, n into n plus 1. Okay, what do we want to say? So for example, this is not a closed form. Okay, this is not a closed form. A closed form is which does not contain a summation. Okay, so for example, ये वाला जो part है ना, this is not a closed form. This is actually a summation. Okay, this is कुछ मैं इसकी sum करके कुछ बड़ी form लिख रहा हूँ. ये जो part है ना, this is a closed form. This is a closed form formula. This is a closed form. Okay, this is a closed form. This is a closed form. Okay, this is not a pure closed form. Okay. So for example, if you have, so there are a couple of rules. यहाँ पे अगर आपके पास एक constant है और उसको आपने sum करना है from one index to another, so you can just multiply that constant by the size of the window. Okay, so all it's saying is that I have a 4, I have a 4, I have a 4, I have 4. So I need to sum 4 from starting from this index to this index. So all I need to do is I need to multiply 4 with the size of the window, which is the number of 4s there are, which are 4 as well. Okay, so if you have to add some constant over a window, you just multiply that constant with the size of the window. Okay, this is the size of the window. The size of the window is n minus m plus 1. Is it clear, Shaviz?
Yes, sir.
Yeah. Okay, similarly, if you have summation which has a constant times some index, so you can remove that constant. उस constant को आप बाहर लेके आ सकते हैं. So in here, for example, you remove the constant बाहर आ गया, and you have a simpler summation, hopefully. Okay. Similarly, you have a sum जिसके अंदर चीज़ें collapse हो रही हैं. So for example, if you look carefully, all it's saying is that subtract the previous element from the current element. Okay, so let's say I have A0, A1, A2, A3, A4, and I need to, I don't know, 4, so on, AN. Okay, and I need to sum AK minus AK minus 1. So what's saying is that AK को sum करो और AK minus 1 को remove कर दो. Okay, so I need to sum this and I need to remove this. Okay. In the next term, when k is 2, I need to include this and I need to remove this. Okay, and in the next term, I need to include this and I need to remove this. अब हो क्या रहा है, A1 की जो टर्म है इसको मैंने एक दफ़ा ऐड किया और एक दफ़ा रिमूव किया, which means कि इसका तो इस फंक्शन में कोई कंट्रीब्यूशन नहीं है. Similarly, जो A2 की टर्म है, I am adding it once and I am removing it once. Okay, which means इसका कोई कंट्रीब्यूशन नहीं है. Similarly, इन सारी टर्म्स का कोई कंट्रीब्यूशन है ही नहीं इस सम में, एक्सेप्ट फॉर द लास्ट टर्म. ओके, लास्ट टर्म को मैं एक दफ़ा इंक्लूड करूंगा और इसको मैं सब्ट्रैक्ट नहीं कर रहा, और जो फर्स्ट टर्म है मैं उसको एक दफ़ा रिमूव करूंगा और इसको मैं ऐड नहीं कर रहा, which means that this whole sum collapses to an minus a0. all other terms are, एक दफ़ा मैं उनको ऐड करता हूँ, एक दफ़ा मैं उनको रिमूव करता हूँ. ओके, तो उनका कोई कंट्रीब्यूशन नहीं है, ऐसे वो कोलैप्स हो जाते हैं. Similarly, collapse could be the other way around, that I add the previous term and remove the next term. Okay, this case में जो collapse होगा उसमें I would get a0 minus an. These are sort of basic
सर ये
tricks.
जो -1 है ये इसके सबस्क्रिप्ट में है.
Where is -1? Yeah, it's in the subscript. It's like this. Okay, so ak -1, yeah, in the subscript. Both cases, यहाँ पे भी subscript में है. Yeah. All right, so you have a sum of sums. आपके पास sum करना है और उसके अंदर जो चीज़ें वापस में sum हो रही हैं. I think we have run out of time, guys. We will continue from here on Thursday. Any questions? We have about a minute or so. No questions. All right, I guess see you on Thursday. We will hopefully have more questions ready for you on Thursday. Meanwhile, you can start on the chapter of sequences. I think sequences are in the sets chapter. जो हमने अभी sets तो हमने उसका part पढ़ा था, sequences का नहीं पढ़ा. But we will move on to induction, which is probably the 6th chapter. तो summation वाला जो part है वो please पढ़ लीजिएगा. उसकी कुछ exercises मैं आपको Thursday को बताऊंगा, and we'll probably have some questions for you homework on Thursday as well. That's the next part. वो हम अभी नहीं पढ़ेंगे, वो बाद में है, वो counting का part है. Okay? So Hadi was asking when are we going to study permutations and combinations. तो वो counting वाला chapter है, तो उसमें भी थोड़ा सा time है. Let's.
Was asked a question.
What?
From you in the chat box. So
What does he say?
grading के बारे में little bit helps.
Okay, send me an email. Okay, grading के बारे में I don't know, मुझे अभी नहीं पता, question भी नहीं पता, तो send me an email. Okay, but counting का chapter हम induction के बाद पढ़ेंगे. Let's finish induction, we'll go to the counting. That's a really interesting chapter too. All right, see you on Thursday. Thanks, guys. Bye bye.